kwa nyimbo zao. Karibu.
So the GCD for these numbers is 2. That is the greatest common divisor for numbers 12, 36, and 64. Now, I want us now we discuss more about the combination of the LCM and GCD. You can get a question which gives us the combination. That is the combination for LCM and GCD. How do you go about it? We have an example here, which I want us to go through, so that at least we can understand what we are talking about. So, let's see ways to get that example. It's a very good example, so that we can learn more about how to go about it. So the question is, the LCM of two numbers is 180. So the LCM of two numbers is 180. And the GCD is 18. If one of the numbers is 90, calculate the other number. So the question is, 180 in terms of factors is automatically 2 power 2 times 3 to power multiplied by 3 to power 2 multiplied by 5 to power 1. So in short, what we are talking about, since the LCM has the greatest power of 2 is 2, the number must have a vector 2 power 2. Since the HCF is 2, 1 times 3 to power 2, the number must also have a factor 3 to power 2. 5 is not a factor of x because it does not appear in HCF. Therefore, x is equals to 2 to power 2 times 3 to power 2, which is equals to 6. So what we are talking about here is this. Now when you look now at the LCM of the two numbers, the number now will be 36. So if you get the LCM of 90 and 36, you are going to get 180. When you get the LCM for, you get the GCD for 90 and 36, you are going to get 18. So that's the procedure that we use when you want to find the LCM and the GCD, or if you have been given two numbers, which maybe we don't know, but we are supposed to find one LCM. So you have to get now what is the LCM, but is not in 90. Then you multiply by now what is in 90, which is the common. 3 to power 2 and 3 to power 2. And basically that's when you are going to get that 6. I think I can give you some example so that you can learn more about how to pass 36 and x. If the two numbers are 36 and x, find the value of x. Find the value of x. 2. That's what will give us 36. Now from here, you've been in a position to relate so that you can see now which is, for example, when you come here, 2 power 2. Thank you very much.
Frozen snowfields and glaciers. The once thriving metropolis they seek has disappeared. A few broken remnants are all that remain, crushed and buried beneath tons of rock. Could this be a future vision of Earth? Naked Science asks, what forces could create such a bleak and barren world? And investigates how the awesome power of colliding continents shapes and reshapes our planet in an endless cycle of construction and destruction. Our world, the Earth, down, mean it's flexible enough to allow the plates above to move up to several inches a year. Evidence for the theory of continental drift was first proposed in 1912 by German scientist Alfred Wegener. He noticed that identical fossils were discovered oceans away from each other. Paleontologist Professor Mark McMenamin of Mount Holyoke College in Massachusetts,
but occurring in very different parts of the world, imply that the continents have drifted.
when he first proposed his theory of continental drift, Wegener was laughed at. The idea that continents could actually move was considered preposterous. The problem was, he didn't know how the continents moved. The missing mechanism wasn't discovered until the 1960s. Plate tectonics is powered by heat.
Plate tectonics is being largely driven by the fact that the interior of the Earth is much hotter than the surface.
The temperature at the center of the core is 10,000 degrees Fahrenheit. It's as hot as the outer parts of the sun. Much of the heat is left over from the collisions and massive bombardment during the early days of the Earth. The rest comes from radioactive decay of heavy elements in the core. Heat escaping from the core creates convection currents in the next layer of the Earth, the mantle. The process is like a lava lamp, where heat from the bulb at the bottom creates convection currents in the oil, pushing the synthetic lava upward. The heat melts part of the mantle and sends plumes of magma, molten rock, rising to the surface. It rises between cracks in the plates, creating new rock that pushes the plates apart.
I think that plate tectonics is virtually inescapable on this planet. It's an exceedingly efficient way to cool the interior of the Earth.
This formation of new rock splits apart and separates the plates and the continents sitting on them. Today, the majority of this new rock forms under the sea, creating vast interconnected volcanic mountain ranges that extend through all the major oceans of the world. One range can clearly be seen at the bottom of the Atlantic Ocean, along the Mid-Atlantic Ridge. It stretches more than 12,000 miles from the subantarctic to the Arctic. It comes to the surface in a few places. Iceland was created from volcanic lava, bubbling up at the junction between the North American and Eurasian plates. It's one of the few places on Earth that one can actually see continents being pushed apart.
We are watching here geological structures that you cannot really watch anywhere else. It's like a big textbook of geology. This is where the Earth's crust is being made.
Paul Einarsson, professor of geophysics at the University of Iceland, monitors the mid-ocean ridge where the continental plates are splitting apart. The ridge in Iceland is almost 3 miles wide. On one side is the North American plate, on the other side, the Eurasian plate. The rift here grows as new rock forms at its center, pushing North America and Europe away from each other. The Atlantic Ocean widens, and the two continents drift apart. Eventually, the Atlantic could become as big as the Pacific. To measure how fast they're splitting, Einarsson takes global positioning system readings at specific points along the plate margin.
We put the antenna right on top of the point, and then we can calculate the exact position of this point in the world with respect to the center of the Earth.
Although the ridge appears calm and there's no magma rising to the surface, Einarsson's measurements show that the two continents are drifting apart by around an inch a year. So by the end of the century, Europe and America will be almost 8 feet further apart. The movement in Iceland is typical of the processes shaping the continents since their birth 4.4 billion years ago. It's part of the great cycle of the Earth's continents. The new crust, created at the mid-ocean ridge, moves away, cools, and eventually sinks back into the Earth. When the first proto-continents formed, there were several interconnecting tectonic plates, constantly bumping and grinding against each other, pushing the new land over the planet. Today, the Earth has over a dozen plates, some colliding together, some moving apart. They are powerful enough to move a continent the size of North America over 3,000 miles in 200 million years. That's 15 miles every million years. The Earth, 3.4 billion years ago, and plate tectonics pushes the proto-continents together. They combine to form ever larger tracts of land. Scientists suggest that cratons combine with other cratons to form a supercontinent, a huge continuous stretch of land. It's called Valbara. Scientists are unsure of its exact shape or size, as only a few pieces, like the craton in South Africa, still remain. But Valbara's days are numbered. A rising plume of heat is growing beneath it. It's about to rip the world's first supercontinent into pieces. $2.7 billion years ago, Valbara, the world's first supercontinent, still dominates the planet. But plate tectonics, powered by heat from the Earth's core, is about to split it apart. Rock is a good insulator. When a continent gets very large, the rock traps heat beneath it. As it gets hotter and hotter, a plume of superheated magma builds up beneath the giant continental mass. The temperature continues to rise, and pressure in the mantle increases. Eventually, the crust can no longer contain the pressure, and the hot lava breaks through, ripping the land apart. You can see this process happening today in Africa. Heat from the Earth's core is ripping the continent apart. A giant rift valley runs from the Red Sea down to Mozambique. Giant cracks are opening up in the land. Volcanoes, like Kilimanjaro, mark spots where molten rock have risen to the surface in the past. In 10 million years, the eastern half of the continent will have split away. The molten lava trapped beneath the giant supercontinent of Valbara eventually smashes through the surface rock. The continent ruptures into several smaller pieces. These bits of land sail across the Earth. But nobody knows what happens to them or what the planet looks like at this time. The Earth is entering the Dark Ages. It is over 2.5 billion years since it was formed. It will be over 1 billion years before another supercontinent forms. The Earth is entering a deadly cycle of destruction and rebirth.
The theory of continental drift suggests that we go through cyclic phases of continental dispersion and then continental collision. And the continents then seem to move apart from one another and then collide with one another over a maybe 100 million year or more time scale.
When a large continent splits apart, the separate pieces travel away from each other, pushed by the creation of new land at the ridge between plates. Because the Earth has a constant surface area, the same amount of land created must be absorbed into the Earth. This process happens at subduction zones at the junctions of plates. At a subduction zone, crust dives down into the mantle to be melted to form new rock. When the plate subducts into the Earth, it brings two pieces of land together. When they collide, a new supercontinent starts to form. It is now 1.1 billion years ago on our timeline, and the next known supercontinent has formed. Its name is Rodinia, and it holds almost all of the continental rock on the surface of the Earth. Still, no one knows exactly what it looked like, but at its heart is an area that will eventually become North America. 350 million years later, the cycle of annihilation and creation starts again as the buildup of heat beneath the surface of the Earth tears Rodinia apart. When Rodinia splits, it forms several smaller continents that for millions of years drift apart and then drift back together again to form Gondwana, a supercontinent in the southern hemisphere. Eventually, after several hundred million years, Gondwana slowly splits apart. Plate tectonics pushed the land back together to create the world's last supercontinent. It's a huge landmass known as Pangaea. All the continents we know today are here, joined together. Geologists are able to plot the continents' relative positions because 350 million years ago, there are numerous species on Earth, each living in distinct regions.
This specimen that I have right here is the first trilobite that was ever described from what is now the United States. It is exactly the same type of trilobite that occurs on the other side of the Atlantic Ocean in North Africa. So we know then that the trilobites in the old and new worlds must have been close together because they're so closely related.
The fossil records show that North America and Europe rest next to one another. The land where New York now sits is next to Morocco in North Africa. The Atlantic Ocean does not exist. The east coast of South America nestles against the western coast of Africa, while Australia, India, and Antarctica are joined to the southeast of Africa.
If we want to look at a picture of the world 250 million years ago, we're going to look at a world in which a four-footed creature could walk from one end of this landmass to the other.
Pangaea is one giant continuous landmass. It not only makes the world look very different, it also has a dramatic effect on climate. Because much of the land is located far from the sea, the climate of the interior changes radically from season to season. It gets very hot in the summertime and extremely cold in the winter.
You don't have the moderating influence of the ocean that we have today. So it's a very different world, and it's a world that in some ways is harsher and less hospitable, at least to life on land.
It's thought that the climate change caused by Pangaea's formation may have played a role in one of the largest mass extinctions on Earth. This event, known as the Permo-Triassic mass extinction, wipes out about 90% of all life on Earth.
It's been called the mother of all mass extinctions. I would consider that the formation of Pangaea, with its climate worsening effects, to be a contributing factor, however, and not the sole cause of the mass extinction.
250 million years ago, and the supercontinent of Pangaea is breaking up. The continents we know and recognize today begin to take shape. Over the next tens of millions of years, South America drifts away from Africa, North America away from Europe. Australia splits off from Antarctica and heads north to warmer climes. The positions of our continents are becoming familiar, although their distinguishable features are not. The world's vast mountain ranges, the Alps and Himalayas, and its great valleys, like the Grand Canyon, are yet to form. They will emerge out of one of the biggest battles in nature, the battle between colliding continents. Earth, 100 million years ago. The continental map of the modern world is gradually becoming recognizable. But a battle is still raging between the continents that will change the face of our world forever and create some of the most extraordinary geological features on the planet. As the continents move slowly across the Earth, crust and rock is dragged back down into the Earth at subduction zones between the tectonic plates. But when continents collide at the plate junctions, sometimes there is a battle for supremacy. If neither plate will submit and drop down to be consumed by the mantle, then both the continents slowly smash and grind into each other. These pinch points of continental collision build mountains. The Alps are the largest mountain range in Europe. Higher than the Rockies, the Alps stretch from France in the west through Italy, Switzerland, and Austria to Slovenia in the east. Their formation is a direct result of a continental collision between Africa and Europe. The story of the Alps begins when the African plate breaks away from the South American plate. It starts moving toward Europe.
Without the plate movement, there wouldn't be any mountain on this planet.
Professor Gerard Stamfli of Lausanne University in Switzerland studies the processes that built the Alps. The African and Eurasian plates start to move toward each other, trapping a third, smaller Iberian plate between them. The three plates collide. The Eurasian plate is pushed downward into the mantle, chopping off the Iberian plate. The Tethys Sea begins to close. As the Eurasian plate grinds underneath the African plate, it pushes the Tethys Sea floor and part of the Iberian plate 600 miles north and many thousands of feet into the air. Rocks that started life on the bottom of the ocean end up at the top of the Alps.
Quite fascinating to imagine that if you are on top of the Matterhorn, you're actually staying on top of Africa. For geologists, Africa stops in the Alps.
Over the next 100 million years, the continents continue to smash together. New mountain ranges start forming around the globe. The largest, the Himalayas, form as the Indian plate charges northward toward the Eurasian plate. It moves at 2 inches per year.
The Grand Canyon is a great scar on the surface of the Earth.
Geologist Ron Blakey has been studying the canyon for over 30 years.
It's just a wonderful place to come face to face with planet Earth.
The Grand Canyon is 277 miles long and up to 18 miles wide. At its deepest, it stretches down for over a mile. The gorge exposes the interior of the North American continent. It's like looking through the pages of a book. Each layer tells a story about the past.
One of the really neat things about Grand Canyon is as we go up the walls of the Grand Canyon, it's just like going through a time machine.
Layer upon layer of rock reveal the geological history of North America, from present day to 2 billion years ago. The deeper you go, the older the rocks. By studying the layers, Blakey can piece together the history of the canyon. He finds some of the most interesting evidence at the very top. Fossils of ocean creatures.
Wow, this bed's the jackpot here. What we have is an extraordinary example of a Permian seafloor. The most important thing it tells us with respect to the Grand Canyon is that this area had to be near sea level when these rocks formed. Now it's 7,000 feet above sea level on the rim of the Grand Canyon. So something had to happen. Either the sea had to fall 7,000 feet, and we're pretty sure that didn't happen, or this landscape had to be uplifted 7,000 feet. We're pretty sure that happened.
250 million years ago, the canyon starts to form as a result of a collision between the Pacific and North American plates. They collide with such force, the North American plate thrusts more than 2 miles upward. What was once seabed rises over a period of 15 million years to form a vast plateau far above sea level. It stays that way for millions of years until it is transformed by water erosion. Six million years ago, several hundred miles south of the canyon, plate movements open up the Gulf of California to the sea. For the first time, small streams in the Rocky Mountains could empty into the ocean.
So if we're starting a stream at 14,000 feet in the Rocky Mountains and carving down to sea level, and the Grand Canyon just happens to be in the way, the Grand Canyon's going to get cut out.
These streams merge to form what is now called the Colorado River. It cuts down through the land, heading toward the Gulf of California.
It took a river to carve the canyon. The water has carved down through the rocks layer by layer by layer, removing material out of the canyon and leaving the great void that sits behind me.
The Grand Canyon is a testament to the awesome power of the continents in shaping our world. Back on our journey, tracing the birth and death of the continents, it is now 20 million years ago. 2,500 miles south of the Grand Canyon, another plate collision is about to take place. The map of the modern world is almost complete. At this time, water flowing freely between the Pacific and Atlantic Oceans still separates North and South America. Over many millions of years, the Pacific plate begins sliding under the Caribbean plate. The pressure causes underwater volcanoes to erupt. Some explode with such ferocity that they create a range of small islands between North and South America. Over the next 17 million years, ocean currents deposit sediment in gaps between these new islands. Gradually, the sediment builds up and compresses to form land bridges between the islands. 3 million years ago, the Isthmus of Panama, a narrow strip of land, finally joins North and South America. It separates the Pacific and Atlantic Oceans. The flow of water between the two stops, and ocean currents must take new routes. This causes yet another change in the climate of our planet. It changes the movement of warm seas around the globe, disrupting weather patterns, possibly pushing the planet into an ice age. Many species are wiped out. The continents as we know them today are formed, creating the nice, hospitable environment for human civilization to evolve and thrive on planet Earth. But how long will it last? The forces that power plate tectonics are still active and will tear our continents apart once again. They will build a new world, one that may trigger another mass extinction and push humanity to the brink of annihilation. A view from space reveals Earth's continents as we know them today. There are 7 in total, but some are separated by a political divide rather than a geographical one. Africa-Eurasia is a supercontinent comprising of Africa, Europe, and Asia. It stretches from the Siberian Plateau in Russia to the Cape of Good Hope in South Africa. A spectacular route across 3 continents, incorporating dramatic climate change, vivid scenery, and diverse cultures. However, Africa-Eurasia isn't the only supercontinent on the planet. Because the Panama Isthmus links North and South America together, they too can be thought of as one vast landmass. And if the Bering Strait between Russia and Alaska were to freeze over, it would be possible to walk from Cape Horn in South America to the Cape of Good Hope in South Africa. A journey of around 25,000 miles. But this won't always be possible, for powerful forces deep below the surface continue to send the continents hurtling across the globe. A process that started at their birth 4.4 billion years ago, and one which will continue long into their future.
What we're observing at the moment is only a snapshot of the Earth's global cycle that has been undergoing for the last 4.5 billion years probably, and will be undergoing, even if we're not around anymore.
The global continental cycle has another impact on our world. It causes many natural disasters. Plate movement creates stress points, which lead to volcanic eruptions. As continents split apart, instability at the plate junctions causes earthquakes that rip apart whole communities. This one, on October 8, 2005, in Pakistan-ruled Kashmir, killed nearly 75,000 people and left up to 3 million homeless. And when plates subduct into the earth, their death throes produce devastating waves. The 2004 Indonesian tsunami is just one demonstration of the terrifying power unleashed, powered by the movement of the continents, have been on the rise. But what we are witnessing is an increase in awareness, rather than an increase in the number or severity of natural disasters.
I think what we're really seeing here is a very raised consciousness of the public. With instant communication abilities, much more publicity is given to volcanic eruptions and earthquakes.
We are observers to only a very short period of the life of the Earth. If we could monitor earthquakes and volcanic activity caused by plate movements over millions of years, we would see a very different picture.
When you look at something over 10 years, you might have 10 major earthquakes. The next 10 years you might not have any, but that's not significant. It just is related to the short period of time that you're making the observation at. When you start looking at hundreds, thousands, and millions of years, all that averages out.
It's impossible to predict exactly when the next disaster will occur. But it is possible to predict where it will happen. The plate boundaries. Map the location of earthquakes and volcanoes, and they line up with the cracks between plates. Plot where these plates will move over the next tens of millions of years, and the future looks bleak for many of the world's cities. So what will our world look like in the future? 50 million.
Aina ya mashairi ni mawili tu. Tuna shairi la jadi ama shairi la kale, na pia tuna shairi huru. Tukajaribu kuelezea ndani kabisa. Nakumbuka mpenzi mtazamaji, tulifikia tukaeleza sifa za ushairi jadi, ambapo tulimamanua kwa kina na tukaweza kufahamu. Bila shaka ninashukuru ya kwamba kuna watazamaji wetu ambao wameanza kutuma maoni yao na maswali. Leo ninarejelea swala ambalo mtazamaji mmoja ameuliza ili niweze kushughulikia, na swala lenyewe ni mizani. Ametaka kujua mizani kwa kina. Japo ya kwamba hili swala tutalozungumzia katika istilahi za lugha ama istilahi za ushairi, wacha nimjibu kwa kusema kwamba mizani ni nini hasa, na ni vipi ambavyo unaweza kuchanganua mizani na idadi yake katika ushairi ama katika mshororo. Hebu tuangalie mizani kwanza. Mizani ni nini katika ushairi? Mizani ni silabi zinazoweza kutamkika. Ni silabi zinazoweza kutamkika katika shairi, ambapo ambapo unapotamka neno alafu zile silabi ama irabu, katika lugha nyingine mnaziita irabu, lakini tunaporejelea katika ushairi zinaitwa silabi. Zile silabi ndizo tunazoziita mizani, kwa kutafuta idadi yake, kwa kuhesabu idadi ya hizo silabi ambazo zinaweza kutumika katika kila neno ambalo liko katika mshororo ule. Hebu tuseme mizani ni silabi zinazoweza kutamkika katika shairi. Pia tunasema kwamba silabi mizani ni ile idadi. Silabi ni ile idadi ya silabi zinazoweza kutamkika katika shairi. Mara nyingi silabi hizi huwa ni 16 katika mshororo moja kulingana na shairi jadi, jinsi tulivyozungumza katika kipindi kilichopita. Tukasema kwamba hizi silabi, hizi mizani ni idadi ya silabi zinazoweza kutamkika katika ushairi. Na bado tunasema kwamba mara nyingi hizi mizani huwa ni 16. Mara nyingi huwa ni 16 katika mshororo mmoja, ambapo ikiwa shairi hilo ubeti mmoja una mishororo minne. Na maanisha nini na mishororo minne? Mshororo wa kwanza ni futahi. Mshororo wa pili unaitwa mloto. Mshororo wa tatu unaitwa mleo. Na mshororo wa 4 ni kituo. Na iwapo mshororo huu unarudiwa katika kila mara na katika kila ubeti, basi ndipo tutatumia maneno kama kibwagizo, mkarara, na majina mengi sana. Huu mshororo una majina mengi, lakini iwapo utaisha na katika kila mshororo mwingine huu mshororo haurudiwi, basi utabaki tu kwa kituo. Hata liwe shairi la mshororo 10, mshororo 20, ule mshororo wa mwisho katika shairi ama katika ubeti ndio kituo sasa. Kwa hivyo sasa tunapokuja hapa tunamaanisha hiki ama huu ni ukwapi. Huu ni ukwapi na huu ni utao. Huo ni ukwapi na huo ni utao. Alafu iwapo ni shairi la mishororo mingapi? Mitatu, huu utaitwa mwandamizi. Lakini hatupo hapa. Hebu kwanza tuangalie lile shairi jadi ambalo linazingatia sheria za utunzi hasa wa kale. Tulimaanisha kwamba kutoka hapa hadi hapa ni mizani 8. Tena huku mizani 8. Idadi mizani 16. Hapa mizani 8. Hapa mizani 8. Yote mizani 16. Hapa mizani 8. Hapa mizani 8. Yote mizani 16. Kituo bado mizani 8. Alafu mizani 16. Utapata kwamba hili shairi ambalo lina mishororo 4 utakuja kwamba kulingana ile hesabu ndogo niliofunzwa katika ile taalamu ya hisabati, utapata kwamba ina mizani 60 na ngapi? 64. Hiyo ni mizani. Na je, hii mizani hasa unaweza ukaishughulikia namna gani? Ama hii mizani unaweza ukaijua namna gani, ukahesabu namna gani ukafikisha hapo? Hebu tuangalie tu ubeti mmoja kwa kiduchu tu, ili tuweze kujua jinsi ambavyo unaweza ukatambua mizani hii. Niangalie shairi moja tu hapa, lakini siangalii lote, japo nitaangalia tu kwa kiduchu, ubeti mmoja tu. Ama tuandike neno sina jambo la kunena. Mimi muambi wa jadi. Muambi wa jadi. Unapotafuta neno hili mizani, utapata kwamba kutoka hapa hadi hapa ni kipande kimoja. Kutoka hapa hadi hapa ni kipande cha pili. Kwa hivyo huu ndio ukwapi. Huu ni utao. Kwa hivyo utakuwa na hesabu. Sina jambo la kunena. Kwa hivyo utapata kwamba kutoka hapa kuna moja, hii ni silabi moja, ya pili, ya tatu, ya nne, ya tano, ya sita, 7, ya 8. Kisha natia kikomo. Sasa utapata kwamba kutoka hapa hadi hapa ni mizani 8, ambapo inakuja inamalizikia hapo. Hiyo ni mizani 8. Pili, tunakuja tunasema mimi. Mi moja, silabi ya pili, ya tatu, ya 4, ya 5, ya 6, ya 7, ya 8. Tunasema kwamba kutoka hapo hadi hapa, ambapo inaisha na D, hiyo ni mizani 8. Ambapo sasa hii na ndicho sasa kina cha kati, na hii D ni kina cha mwisho. Lakini licha kwamba tunakiita kina, basi ni silabi kivyake, ambapo sasa idadi yake kuanzia huku mpaka huku ndiko tunapata mizani 8. Ndipo tusema sina jambo la kunena, mimi muambi wa jadi. Huu ni muambi wa jadi. Kwa hivyo mizani, swala la mizani tutakuja kulizungumzia na tutakuja kulishughulikia kwa kina zaidi ya hapa. Kwa hivyo hebu tuangalie mahali ambapo bila shaka tunastahili kwenda, ambapo saizi tunafaa tushughulikie umuhimu na dhima ya ushairi katika jamii. Je, ushairi unatufaidi na nini? Ushairi unasaidia na nini? Mtu anapojishughulisha na ushairi hasa, yeye yani atatambulika kwa nini? Yeye ataitwa nani? Ama yeye atafaidika na nini? Watu wengi kusema kwamba kwa kweli eti Kiswahili hakina faida, japo hawajui kwamba Kiswahili kina taaluma mbalimbali ndani yake, licha ya kwamba ni somo na ni lugha tu. Umuhimu au dhima ya Kiswahili ya ushairi katika jamii. Dhima ya ushairi. Tulisema hapo awali kwamba ushairi ni tungo tu ama nudhuma au nudhumu, ambapo mwandishi yule msanii anatumia lugha fupi kuwasilisha ujumbe wake kwa jamii. Naam, vipi ambavyo huyu mtu atafaidika anapowasilisha ujumbe huu? Ama atasaidia vipi jamii anapojikita katika ulingo wa kutunga mashairi? Kwanza, ushairi huelimisha. Ushairi huelimisha. Ushairi huelimisha vipi? Ushairi, mtu anayetunga mashairi huwa anatoa funzo fulani kwa jamii, ili kuhakikisha kwamba anaelimisha jamii kuhusu jambo fulani ambalo katika maisha ya jamii itakuwa ni muhimu. Kwa hivyo utakuta kwamba wale watu ambao watakuwa wanafuatilia zile nasaha na ule ushauri atakaokuwa akitoa katika ushairi wake, bila shaka watapata elimu na wataelimika zaidi. Kwa hivyo utakuta kwamba huyu mtaalamu atakuwa amefaidisha jamii kwa kuelimisha. Mtu anaweza kuelimisha jamii kwa mambo gani? Kwanza, unaweza kuelimisha jamii kwa mambo ya kuhusu ukimwi. Unawaelimisha